In the serene landscapes of rural Texas, an unexpected predator lurks beneath the tranquility, not a creature of fang or claw, but a virus originally born in the skies. Recent reports have surfaced, distressing and peculiar. Domestic cats falling fatally ill after consuming raw milk, suspected to be tainted with the bird flu virus. This alarming situation prompts a pressing question. How has a pathogen traditionally associated with avians begun impacting mammalian life through such an unassuming vector? In late 2023, veterinarians in Texas noted an unusual spike in feline mortality linked to renal failure, triggered by an unfamiliar strain of the avian influenza virus. As investigations deepened, the common element among the deceased was their diet. All had ingested raw milk from local dairies. This unexpected vector of infection presented a novel challenge for veterinary and epidemiological sciences, sparking an urgent need for answers about the transmission dynamic of this deadly interaction. Pathologists and virologists teamed up, retracing the route of transmission and scrutinizing both the biological properties of the virus and the environmental conditions that favored this unnatural spread. Their studies highlighted a critical oversight in biosecurity measures currently in place, emphasizing the complexity and potential dangers of indirect routes of transmission. The scientific community rallied, pooling resources and expertise in a race against time to prevent further outbreaks. The urgency was palpable, given the potential for the virus to spill over into other species, including humans. At its core, bird flu is an avian disease, predominantly spread among birds. However, the strain H5N1, known for its ability to infect humans and other mammals, had undergone a mutation, enabling it to survive in the digestive tracts of cows, a rare host for avian viruses. The virus's survival in milk, typically a benign medium, stunned researchers. This revelation prompted a reevaluation of the virus's capabilities and resilience, altering previous understandings of transmission vectors and host range. The scientific analysis did not stop at merely observing this anomaly. It probed deeper into how the disease managed to maintain virulence after passing through another species. Studies conducted revealed that specific proteins in cow's milk might be preserving the virus, acting almost as a preservation medium, which could keep it active long enough to infect the cats that consumed it. This segment of the research drew attention to the complex interactions within ecosystems and the unforeseen pathways diseases could exploit, possibly due to evolutionary adaptations or environmental pressures. The crises led to scrutinizing local dairy farms, where lapses in sanitary measures and biosecurity protocols became apparent. Most impacted farms had minimal controls for interactions between poultry, the carriers of the bird flu virus, and livestock like cows. This oversight facilitated the initial virus transmission, highlighting a critical vulnerability in farm management practices. Advisors from agricultural departments and veterinary health officials collaborated to overhaul these practices, focusing on implementing stringent separation zones between different types of livestock. Training sessions were conducted with farmers to enlighten them about the risks and necessary changes in handling livestock and produce. This preventive approach aimed not only to curtail the immediate threat, but to establish long-term strategies to mitigate similar crises in the future, ensuring sustainable and safe farming practices that protected all facets of the farm's ecosystem. The implications ripple far beyond the feline victims, shedding light on the intricate and often overlooked intersections of animal health, agricultural practices, and public safety.